Hello everyone, I'm Zeki Vázquez, and I'm going to talk about Drupal strong scaling. This is basically a presentation about a case of success on a project that we did 1 year ago. I'm going to focus on the infrastructure part, which is the most important part here. The Drupal just acts as a CMS. I'm going to explain later all the problems that we found as a team and how we solved them. So, well, let's start. First, I want to introduce myself so you know a bit more about me. My full name is Zeki Vázquez, but everybody knows me as Zeki. I focused since 7 years ago on backend development, backend web development. And lately, on the last 3 years or so, I have been working as sysadmin and DevOps also, in addition to backend development. And also I am pretty focused on hacking and security. I also perform security audits, especially on web applications. And I have been a speaker on conferences since 2013. I currently work on Swift Circle. This is my company. We are a small team of Drupal experts, and we perform a lot of development, consulting, etc. We do basically a lot of stuff. And I want to talk about not everything is code, not everything is it's source code and technology. So I want to talk about my personal life. I live in Jerez, which is pretty close to Malaga. It's 2 hours riding on a car. And I want to mention that on the region, on Cádiz province, we have the best beaches on the world. And this is, for example, the Sahara de los Atunes. I really like to spend some time on this kind of paradise. This is Kero. This is my pet rabbit. I really like to show him. It's free on the house. This is my guitar. I play on a rock band, and this is my electric guitar. And I recently bought this bike, a Harley Davidson Iron 883. So this is my details on personal life, and let's focus on what we have been, on what we want to talk about here. So this is basically the contents of the presentation. First of all, I'm going to make a small introduction. I will talk about Drupal and containers and the technologies, but in a very global way. Then I will focus on describe the project, and the analysis of the project and all the schemas that we did and how basically it works. Then the third point will be about the problems and how we solved those problems, the solution that we took, and then a small bunch of conclusions. Pretty simple. So first, as an introduction. First of all, what's Drupal? Anyone here has experience with Drupal or PHP development? Okay, great. That's quite good. So basically, Drupal is a CMS, a content management system written in PHP. It's extensible. We can implement modules which add functionality, themes which are the visual styles also, and external libraries. It follows a LAMP architecture: Linux, Apache, MySQL, and PHP. But basically, this you can use Nginx, you can use Postgres, etc. It's free software. We are currently on Drupal 8. This is the latest version that went out on last November. But currently is not ready for being used for big projects. Because we have to migrate a lot of important, relevant, contributed modules to this version from the previous one. And the best of Drupal is the community, all the people that are behind the tool, all the human souls that we made Drupal. And they help a lot, and well, basically, it's the best part of this software. So, once we know Drupal, what we do to improve PHP or Drupal in this case, performance, scalability, and availability. One of the biggest problems on Drupal is the cache. I mean, the performance. You need the cache for almost everything. You need to use For example, these tools, Memcache, for example, by default, Drupal uses tables on the database to store the cache stuff. So we want to use Memcache or maybe Redis to store that information instead of on the database on memory. Then we can use APC or OP-cache. PHP is an interpreted language, so we want to store the byte code, let's say, the machine code, on memory, and then we don't need to access the files again to execute something. We use Varnish, for example, to cache the HTML, so we don't have to worry about PHP and HTML processing when an anonymous user comes. We just return the HTML directly, which we have been caching. And for redundancy, basically you still add a lot of Apache servers, and then you have a load balancer or two of them to control failover. And then on Drupal itself, we have a lot of cache improvement modules. For example, Boost, or for example, AutoCache. Well, you can choose. You can imagine that some part of the budget on a project, on a Drupal project, goes to the improvement of performance. And well, that's true. On Drupal 8, this has been improved, but again, we depend extremely on cache. And once we have mentioned this, I want to move to the other bunch of technologies that we use it on the project, which is cloud computing and containers. The main purpose of cloud computing, the main advantage, is the elastic computing, which basically means that resources grow on demand. I mean, if you receive a high peak of traffic, then your resources go scale up as needed, and then when your traffic goes down, then you remove those extra resources, so you don't have to pay more for them. In theory, all the cloud providers sell this as, hey, you are going to get full scalability and full availability, but this is false, okay? Because unless you have thought about how you deploy your different instances or your different containers on the cloud environment, if one CPD on this cloud provider goes down and you have all your code on that CPD, then everything messes up. So you have to be very careful with this stuff. And again, the problem with the cloud providers is the budget. They avoid to mention, they sell, hey, this is wonderful, this is the future, this is the present, etc., blah, 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 blah. But then when you start to creating machines and services and start using everything, then you get a big bill. So you have to control this because, for example, Amazon Web Services provide a calculator, but, this is not just an approximation. It's not true. And about containers, Docker, I have seen many people using Docker containers just as a local virtual machine for developing. And, basically this is not the target, the goal for Docker. So yeah, I will leave in there this question. Is only for local development, for local environments, or it's only for content integration? This kind of thing. Can you use Docker in production? That's the question. My answer is yes, and we will see. So let's go to the project. Okay, I'm going to describe the project on this section. And basically, this is the base requirements, some of the base requirements that we had on the beginning of the project. So the project started on last quarter of 2014, and they wanted to build a Drupal 7 multi-site install. A multi-site install on Drupal, for those who don't know, is basically you have the same code for a bunch of sites, and then each site has its own database, and its own directory for the files uploaded by the users. So, if you have 2, 3, 10 sites, it's okay. But when you have to think at 30,000 sites, you have to think on 30,000 databases, and they want to scale up to 100,000 sites in a couple of years after the projects went live. So this is the first challenge. It's quite complicated because we were not used to this scale of projects. We were used to small sites or maybe high traffic sites, but only one site, not so many sites. And they had problems with the previous version of this project because this was also built in another technologies before. This was a project that had been running for, I think, 5 years or so, and they had a lot of problems because the former provider, the former coders didn't take into account the scalability features. So business, the business layer, the people from business, they wanted an availability of 100% or almost. They didn't want to manage something like users complaining because my site is down, I'm losing money, etc. No, they wanted to be pretty confident, and they wanted to sleep at night, which is one thing that we want all on this IT sector. Of course, high performance. I want the sites to be pretty fast, and I want to pay the lowest budget possible, as always. So we have a lot of sites, and we need to control the site creation. When you create a site on Drupal, you can just go through the UI, or you can use Drupal shell, which is a tool to execute Drupal commands on command line. But of course, we want to do this in an automated way, and we want to be able to create a huge amount of sites on one command. I will explain a bit about the project. This is a company which offers training. Okay, it's like a private university, and for each student they give as a present, let's say, when the student graduates, a website. And they had at this point 30,000 students, and they were planning to have a lot of more students on the next years. So that's why each class was formed for about 2,000 students each, because it's online training, etc. So that's why we need to control the site creation from an external point of view. We simply can't use Drush site install, and do it manually, so we need to automate this. And again, another problem of the previous version was the deployments. They lost a lot of time, the uptime, I mean. When they perform a new deployment, then the site was down. The sites went down for a couple of hours. A lot of students complaining. Again, they wanted to be confident about the system being robust and solid. Again, to manage Drupal, we need to be able to execute Drush commands on the site. For example, for cache clear, for installing modules, etc. For the maintenance, we need to execute it. But again, we have a huge amount of sites. So execute a single command on each one of them. It's a pain. So it was hard, and we need to talk about some way to do this quickly and in a solid way. Of course, we're talking about a new version of a software that is currently running, so we had to plan for a migration from the previous platform. This is, at first, not a problem because Drupal has the migrate module, which is wonderful. It's the best migration tool that I have used on some years. At first, it didn't look so scary. This is an important part. We were a 3-people team only. We had a front-end developer, a back-end developer, and a person who did developing and also some operations stuff related to the infrastructure. I was the DevOps man on this team. But you can imagine that it's a very big project, and only 3 people all these requirements, it was a bit crazy. So our faces, when they told us this, was like, what? We were not used to tackle this kind of projects, so we were surprised about what they were asking us for. So that was our face. Basically, we ran a bit on panic, we fleeing on panic, but hey, stop. Let's think about it. Okay, it's true that we cannot consider the usual technologies, a usual stack of a lot of machines, Apache machines, and a couple of load balancers. Yes, we can use that, but maybe it's not the best option to scale up in time. I mean, so if we are expecting to grow like 3 times the number of sites on 2 years, then we need some dynamic technologies to allow us to scale up, to cover the needs. And well, it was a challenge. We are computer scientists, we are engineers, so let's face this and let's do it, of course, with open source. God bless open source. We started to take a look to the infrastructure and containers and all the stuff related, and we discovered about Apache Mesos and a couple of other tools, and then we started to test, to perform some tests, etc. And in addition to this, we considered this cloud computing, this fashionable way of doing a lot of easy deployments of new machines with just a couple of clicks or with an API, so we can automate everything. This is one of the most important parts on the project. And of course, once we considered Docker, okay, we started to think, okay, a lot of people say that Docker is not production ready, but let's try. If in our use case it's useful, and yes, it was. In fact, we have Docker containers on production. And yep, again, we performed a lot of tests, and we saw the results were okay, so let's go with it. And desperate times became funny times. This is the technology stack that we use it on the project. On the center point is Drupal, which is the CMS that we use it to perform each one of the sites, of the student sites. So it was pretty easy. They had the students a menu. They can add some nodes of content, playing pages, some blog feature, events lists. Typical content management system. And well, we used Amazon Web Services as the cloud provider. So Amazon has a very powerful API, so we can basically automate everything. We had our infrastructure in code. That's great. Then we have Apache Mesos. I will explain later how this combines. On top of Apache Mesos, we had Marathon, which basically allows us to run Docker containers on top of Apache Mesos. And now looking on the application layer, we have Nginx instead of Apache. We configured it in a different way, then it worked right. We used Node.js for a couple of tools that we needed to control the sites. We used MySQL and MongoDB also. It's not so common to use MongoDB with Drupal. I will explain later why. But basically, MongoDB is not good for doing, joins or queries, advanced queries, etc. And Drupal uses advanced queries because, for example, on each field of a content type is like a piece of information, okay, and it's made of fields. Each field on Drupal becomes a database layer on a table. So to extract all the information from a single page, from a single node, from a single piece of content, you need to do a lot of inner joins. So MongoDB is not an option, but you can use for some tables. You can use for some pieces of the project, and we used it, and we discovered that it's a pretty good tool when you use it on the correct context. And to orchestrate everything, we use it Ansible. Which is pretty well integrated with the Amazon services. The cloud modules from Ansible are pretty good to manage Amazon stuff. So I will start now to describe the different pieces of the project. And first, I'm going to focus on the web server. This is pretty simple. We had Drupal over Nginx and PHP FPM. Nginx allows a really flexible configuration. We had to implement a lot of tweaks, and it behaved with high performance. PHP FPM also, and just as a curiosity, we implemented mod security with custom rules from Drupal, because the core rule set from OWASP for mod security is not good. It does not behave well with Drupal. There's a lot of false positive, and it's not good by default. So we modified the rules. Then we had a Node.js app, which is basically the app that we use it to control the site management. We created and enabled and disabled sites from this Node.js app, which is basically a list of sites stored on DynamoDB, which is the NoSQL database engine from Amazon. So, we basically were managing this table, this NoSQL table, with this application. And we implemented, again, an API to allow batch operations on sites list. If you remember, we need to create a lot of sites at once. So we implemented some queues model and etc. That kind of stuff. Later on the presentation, I will talk about why we decided for Node.js in this case, but basically it's related to the fire and forget feature that provides the asynchronous stuff. I mean, you execute something, and when it finishes, you don't have to worry because it has its own callback, and that was very useful for us. So we are going to iterate on the project from the top to the bottom. Okay. And first, I'm going to start with the Drupal container. Okay, we needed a stateless Docker, stateless Drupal container. Why? Because we need to be able to destroy and create new containers, new running containers, without losing any data. So all the data, volatile data or persistent data, which was Memcache, MySQL, MongoDB, all those services had to be out of the container. Okay, first, it's basically we use for MySQL we use RDS, which is relational database system on Amazon. For Memcache, in this case, we use Elasticache, which is again virtualized Memcache servers on Amazon. For MongoDB, we had to create, we used Mongo MMS, which is an external way to manage MongoDB installation inside of the EC2 container, EC2 instances on Amazon. We used S3 to store the uploaded files from the users. And this is a great discovery. The S3FS module, it's a Drupal contribute module, basically allows you to forget about the S3 integration. You just install the module, you tell, hey, this site is going to use this subdirectory on the bucket, and then you forget. It's the integration is pretty simple and pretty good, and it behaves in a good performance. So emails were sent through Postmark, which is an external service, and we used New Relic inside of each container to monitorize the PHP behavior. So everything, you have the Docker container, had the web service, the Nginx, the PHP FPM, and the code, but everything was out of the container. So if we kill a container and then redeploy, then we have lost nothing. From these containers, okay, remember Node.js application is one container, then the Drupal web server is another container, images, and we implemented these images. Then we implemented a cluster using Apache Mesos and Marathon. Basically, Mesos abstracts some machines. If you have 3, 4, 10 machines, then Mesos makes them to look on the top of this abstraction layer like one single machine, where all the resources are available. For example, if you have a 8 gigabytes machine, let's say, then you see all the cluster as a 32 gigabytes machine, for example. That's all. And on top of Apache Mesos, you can just use some frameworks, some tools like Marathon, which basically allows you to run Docker containers. Marathon is because these are long-time service applications. That's why the name comes. And Kronos allows you to run cron jobs inside of the containers, which it was a problem at that point. So we use these two frameworks on top of Apache Mesos. Great point on both Marathon and Kronos. Both tools work with an API, so again we could automate everything, and well, basically automate all the stuff. So we had two Mesos masters. You know, you have masters and workers. Masters were basically receiving the connections and then distributing them on the workers. And we used Zookeeper to orchestrate everything on this tool, to manage the discoverment of pieces and elements and so. And we had a bunch of workers, which was basically this an AutoScaling group. On the next slide I will talk about it. And a main worker. I will explain later why. But basically this is the cluster schema. Okay, have in mind, it's pretty simple. And on top of the workers we have our Docker instances running. So this was pretty good. Okay, that this will allow it some kind of scaling. But that was not enough, because if we hit a limit on, for example, if we had 4 workers and then we receive a high peak of traffic, then we are dead, because we can't add manually the stuff on other machines or so. So we used our AWS AutoScaling Group feature. What we did, it's pretty simple. All those Mesos workers, which were basically the same machine replicated different instances, then we implemented an AutoScaling group to have it grow and reduce depending on the traffic. So a couple of tricks. The AMI, when you create an AutoScaling group on Amazon or whatever cloud provider that you use, you make a system image and then you use that image to redeploy another instances, which are clones basically from that original machine. So Marathon needs to pull the images from Docker, from your Docker hub, and then it launches. But what we did is before creating the AMI, we downloaded the last versions of those 3 Docker containers, Docker images. So whenever we create a new Mesos worker on this group, whenever high traffic comes and then a new instances grow up, then it has not to lose time by downloading the images. It's basically taking 20 seconds to have a new machine up and running, integrated on the cluster. It's pretty cool. And that's it. We synchronized the amount of Marathon apps with workers. We used this main worker to store 2 containers, which were the Varnish container and the Node.js app container. Okay, and then on the AutoScaling group, we had on each machine 2 containers with the Drupal Webserver. So whenever we scale up this group, then we have 2 new containers with Docker web servers and integrated on the load balancing, and that's it. Basically, this is the architecture of the project, and I will talk now about a couple of more details about the deployments. Again, automatization. This is a core feature of the project. I really like this sentence. Lazy DevOps is best DevOps. If you have everything automated once, then you don't have to worry about coding everything again. You just need to tweak a couple of details of your scripts, and then you are you are done. You can redeploy easily. So we used Ansible, and Ansible, as I mentioned before, integrates in a very simple and powerful way with Amazon Web Services, because it has a lot of modules, cloud-related modules, and specifically with Amazon. And it's great because I want to create a new instance and I want to provide with an Apache or blah 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 blah. You just have your playbook ready, you execute the playbook, and then you are done. It will create the load balancer, elastic load balancer, the instances, etc., everything. And another trick that we applied on this project is this combination, Makefile and Dockerfile. If you remember, when you create a new Docker file, then you have a lot of instructions, and you create basically the static part of your machine, of your container. This is basically installing the packages from the operative system, applying some configurations. That's okay. But then when you execute the Docker container itself, you are providing an entry point, which is a command that will execute once the Docker container is up. What did we do? Use Makefile as the entry point. That way we can execute a lot of stuff, a lot of code inside of the Docker container. I mean, what we did, for example, running the service of PHP FPN, running the service of Nginx, depending on the container, performing some changes of permission, etc. Some kind of applications, but inside of the Docker file, of the Docker container, sorry. So it's a really good idea. And Makefile, you only need to install the package make on the operative system to have it available. And the result was we were able to create and destroy environments with just a single click, well, a single command, a single push. This was very interesting stuff, because the QA team, they wanted to test each one of the new features independently. And well, basically, we were not creating a new full environment for each branch, but we easily could extract that part from the playbooks and then let them to create new environments. And additionally, when the test load the stress tests came, then it was very easy to create a couple of environments to basically attack with Gatling or Gmeter, or on those tools to stress test the applications. And we, as developers, we could continue working on our environments focused on code. And again, some extra details. We created our own recovery plan, because Amazon provides some backup system, but it's not enough. You have not too much control. You can, for example, take a snapshot of the MySQL instance, but it's not enough. Then you have firewall, which is security groups. We use it protection for all the REST APIs, and this is a detail that I like. Log centralization. Mesos provides some directory where inside of the workers, where you can basically add files, and those files are then accessible from the masters. The masters provide a web interface, so you can access all the contents of those files, of those directories. And what we use this for? We all the drush commands that install new sites, we used this directory to store the logs, and then we had the logs available to automatize them with Elasticsearch and Kibana, etc. So that's a great stuff here. Then I will talk very quickly about problems and solutions that we found. So let's think. 30,000 sites on Drupal means the same amount of databases. And taking into account MySQL uses one folder per database and one file per table, and having into account that a Drupal install has average 2,000 tables, you can imagine this is unmanageable. So it's not an option. It's not an option to have a single database for each single site. In addition, MongoDB has the problem that when you create an empty database, then you have pre-allocated 600 megabytes. Then when you have 601 megabytes, it will pre-allocate 1 gigabyte. So there's a lot of empty space, but that space is pre-allocated. You cannot use for another stuff, and that's a problem. So the MongoDB uses this feature exponentially. I mean, when you use 2 gigabytes and some peak, then you have 4 gigabytes pre-allocated, so you cannot scale up too much. You want to slice this on different databases. So this is manageable, and our solution was divide and conquer. Basically, we identified each site with a hash, SHA-1, SHA-1 hash. We used this hash as a prefix on tables on MySQL, and we grouped sites, each 500 sites per database. That means for 30,000 sites we had 60 databases. Yep. 60 databases, and on each database we have the information for 500 sites, and all tables Drupal can make distinction of these tables using the prefix. And for MongoDB we use the same system, so the maximum database size on each database was nearly 4 gigabytes instead of 60 gigabytes, if I don't remember bad, that we get on some point. And the number of tables that we get on each MySQL database is 62,000 approximately, which is manageable. We're not talking about nearly 500,000, but a number which is manageable. So this is the system we use it to manage the problem with databases. I'm going to describe what we did on Drupal settings.php file to manage the sites. So we received an HTTP call for a specific subdomain, which was a site, and then what we did was connect to DynamoDB and ask DynamoDB, hey, this site, where is the database where the information for this site lives? Okay, the database is the database number, for example, 30. Okay, then we calculate the hash from the domain name, and then using the hash and the number of the database, Drupal knows how where to look for the information. Then we store the database reference on main cache. Then so we don't have to bother DynamoDB again, because this information is not going to change, and then we are done. Then we can let Drupal work as usual. We had a problem which was a site creation timeout. I mean, when we were to create a new site, we received a timeout, and it was not from Nginx, it was not from Node.js, it was not from PHP. So we implemented the fire and forget system that I talked before. We just ordered a new site to be created, and then we had an API endpoint to receive the answer from Drush. And that's it. Once the project was on production, we discovered the problem was on Haproxy. But well, it was worth, because we implemented a lot of performance tweaks on both PHP FPN and Nginx. That's why I discovered on that point why Nginx is so powerful, and that this is why I use this joke in Soviet Russia: Nginx configures you, because there's a lot of options on Nginx to configure and to tweak the performance. And another problems, we found an instability on AutoScaling Group. That's why we used the main worker and the AutoScaling Group of different workers. We had the problem that once in a while, when we were stress testing the system, then sometimes all the systems were down. And the problem was that when scaling down, some workers were extracted and destroyed, and when the varnish endpoint was removed on this way, then the request could not reach to the web servers, and we had the system down. So that's why we had a main worker with the Node.js and Varnish applications, the containers, I mean, and then we had only Drupal containers on the AutoScaling group. That way, no matter how scale up or scale down we get, they are going to be always available, both the Varnish and Node.js containers. We ran out of space on the MongoDB instances when doing the migration. That was a crazy couple of hours until we realized what was happening. But take into account that if you use MMS for MongoDB management, it allows the EC2 instances with 50 gigabytes on disk. So be aware of that. And well, basically, I want to mention also the remote and massive Drush execution. We used a system, a QE system on the app, Node.js app, to execute this kind of stuff. We were talking about today we have 80,000 sites approximately on this system, and we took only 6 hours to execute a Drush command on all sites. 6 hours is pretty few because each site, an average, for example, cache clear instruction takes like 20 seconds per site. So do your calculations, and well, it's pretty good. And that's it. Well, there's all other details that I can talk later about. You can ask me on the questions turn. Finally, I want to. Well, I have time. So the problem with PHP FPM, we have a lot of instability when executing PHP, and we discovered that you have to you want to turn off the slow log directive if you want to have better performance. We use it only what we at first tried to use one single bucket from S3 per site, but we discovered that you have a limit of 100 buckets on your account, and you have to ask Amazon to increment that number. So fortunately, we found the S3FS contrib module on Drupal that allows you to use only a subdirectory on the bucket for store the files. And well, the migration was done on 3 days, which is basically a great success, because each migration had to take files and had to take information from the database, and it took like 6 minutes per site. And we had the deadline. The deadline was fixed, and we had to accomplish on that time. And we implemented basically parallel execution for this. And finally, the RDS speed detail. If you use the database instances on Amazon Web Services, the more amount of disk space that you allocate, then the more speed that you get when processing the information. That has to be that is related with the I/O, the reserved I/O for the instance. So the bigger, the better. Finally, the conclusions. We went live on April 1st last year, and it's not a joke. I myself learned a lot of about new technologies, Apache Mesos and that kind of stuff, infrastructure stuff, was new for me, and you know, this project was a success, and I'm very happy to know that the project is still online and working and scaling, and it behaves pretty well. So the combination of cloud plus containers is a profit. We did not use the new Amazon ability feature to execute containers directly on the cloud, because we started before the project before they released this feature. So that's why we used this kind of monster. And one conclusion that I really like, well, I knew it, but this is a new demonstration for this. Drupal as a framework is pretty flexible. It can integrate with almost everything, and when you know how to use it, it's amazing. It's a great tool. Well, basically that was us success. We had a big project done in 5 months. And this project was implied a lot of new technologies for us. So it was amazing how. Well, I am surprised nowadays when I look to the logs on the project and I see that the project is still up, running, and without problems. So thanks for listening. And well, is there any question? Thanks.
Thanks for your talk. Have you evaluated Docker Swarm for as a replacement of Mesos and Marathon?
No, we have not considered to modify the infrastructure. Docker Swarm sounds like a good option for this kind of project. But again, we were newbies on this infrastructure stuff.
It wasn't production ready back then, so...
Yeah, I can imagine. No, I will take a look, but I don't think business layer, the people from business want to change something that is working really good. I mean, the system is pretty stable, and we have had 0 downtime. I can proudly say this. So, there's a lot of pieces. It's a Frankenstein monster, but it works, and it works fine. So maybe in another project similar to this, we will consider it, of course. I am always willing to learn new things, but not for this one.
Thank you.
Thanks.
Any more questions?
Okay, I will be around on lunchtime if anyone wants to talk or ask questions or whatever, or share a beer. Just look for me and we can talk. Thank you.